Okay, in this week's video, we're going to talk about similar right triangles. And over here, I have a diagram of a right triangle, right? Triangle ABC is a right triangle. And if I were to draw from a vertice of angle B all the way to the opposite side such that it's perpendicular, this side length is actually called the altitude or the height. Now, those of you who study areas of triangles, right, I told you the formula was 1/2 base times height, right? This could be the base, and this is the height. Now, remember, the height is always the perpendicular, right? So one way to calculate the area of this triangle, even though that's not the point of today's lesson, right, is area is equal to 1/2 AB times BC, right? AB times BC, right? In this case, this would be the base, and this would be the height. Okay, so base, and then this is the height. But if you were to drop this down, right, this could also be the height. So in other words, you could say area is 1/2. This would be the base, right? This would be AC, right? That would be the base. And then the height is, again, it's always the perpendicular distance, right? The perpendicular distance is from here to here, and the height would just be BE. And I'm sure if you were to actually have some numbers, right, you will see that these two answers would be the same. Okay, so there are some questions in your homework that talk about altitude and height. Remember, there's many different ways of drawing the height in a particular triangle, long as it's the perpendicular distance from one vertice to the opposite side. Okay, so back to what we're talking about today, which is about similar triangles. If you were to, sketch out this big right triangle, which I did down here, right? Again, I drew the triangle ABC without this little extra line. Oftentimes that line confuses students. You would see that you have the big right triangle, right? You also have this triangle here on the bottom. I guess you'd call this second biggest. And then the, the triangle here on the upper right. And I line it all up, right? Such that, the 90-degree angle right here is on the right, okay? So, if I were to sketch this triangle, lay it flat, this will line up with this, right? When I say line up, the the angles will kind of correspond, and the side lengths are, proportional, right? And if I were to draw this triangle right here, lay it flat, it would look something like this. Okay, so now you can visually see, right? Big triangle, left triangle, and then this triangle here on the right is laid flat over here. Okay, so the point of today's lesson is that all three triangles are similar to each other, and I'm just going to quickly explain to you why they're similar, right? Okay, so you could say that triangle ABC, is similar to triangle AEB. And the next question is why? Well, they both have angle A, right? And they both have a 90-degree angle, right? Angle ABC is congruent to angle AEB. And so when you have two angles that are congruent to each other, this is congruent to this is congruent to this triangle is congruent, not congruent, they're similar to this triangle by angle. Okay, so we just established that this triangle is similar to this. Let's stick with the let's stick with the big triangle here, right? I could also say this triangle is similar to this one. Now you can see that angle B is congruent to angle E, right? They're both 90 degrees. Triangle ABC is similar to triangle BEC. Again, why? Angle B is congruent to angle E, right? They both have a 90-degree angle. This right angle is congruent to this right angle. Sorry if you can't see that. This right angle is congruent to this right angle. If I lay it flat, you can clearly see that angle B is congruent to angle E. Or if you want to be more specific, angle BEC congruent to angle ABC. Okay, so I need two angles to use my angle-angle theorem, right? These two angles are congruent. And they both have angle C, right? They both share this top angle, right? This top angle, angle C. They both share it, right? Angle ACB is congruent to angle BCE, right? ACB is the same angle as BCE. And if these two angles are congruent, these two triangles are similar because we established that two angles are congruent by angle-angle. Okay, so far we established this is similar to this is similar to this. The last thing we need to prove is that these two triangles are similar to each other, right? This bottom left and this upper right. So how do we prove that? Well, we're going to say triangle AB. I guess it doesn't really matter which order you go. Okay, I'll say triangle ABE is similar to triangle BCE. Long as the letters, long as you write the letters in the correct order based on the positioning of the triangles, it's okay, right? If I said triangle AEB is similar to BEC, that works as well. Okay, so clearly these two angles are congruent, right? So I'm going to say angle AEB is congruent to angle BEC, right? They're both right angles. And if you were to look at your original picture, right, AEB is this angle right here, and angle BEC, which is this angle right here, right? So they both have that 90-degree angle, right? If this is 90, this is 90. Okay, but we need one last angle that's congruent to use the angle-angle theorem, right? So can you say angle A is congruent to angle B? No, they're not the same angle, right? Angle A is right here. CBE, which is this angle right here, it's kind of, you can't just, eyeball and say they look, identical, right? And so what I wrote over here on the bottom, I said, how are angle ABE and BCE related? Well, where's ABE? ABE in my spaced out triangle right here, that's not in the original picture, is right here. And BCE is right here, right? How are they related? I don't know if they're quite identical just yet, right? Or congruent. But let's see if we can prove it. What I could say about angle ABE, right? This angle right here, and this angle, which is CBE, I could say that angle ABE and angle CBE, this angle right here, are complementary, okay? So angle ABE and I'm going to abbreviate, complementary to angle CBE, right? Again, if you're not sure what is complementary, right, it just means they add up to 90 degrees, right? This angle, ABE and CBE, are complementary. These two angles add up to 90. Why? Because there's a 90-degree angle marked there, and that's the definition of complementary, okay? Okay, now take a look. Angle BCE, right? My question was, how's ABE and BCE related? Angle BCE, which is right here, right? How is this angle related to this? Well, notice this is a right triangle, right? This is 90, and I don't know what these two angle measurements are, right? These tiny angles, this angle right here and this angle right here. But I do know that whatever these angles are, right, you know that the sum of the measures of a triangle add up to 180. You could say that angle BCE is also complementary to angle CBE. Okay, so angle BCE is complementary to angle CBE. Let's go back and look at that, right? Angle BCE, which is this angle, is complementary to this angle, right? These two angles have to add up to 90. Therefore, I can make that statement, angle BCE is complementary to CBE. Okay, now take a look at these two statements. ABE is complementary to CBE. BCE is complementary to CBE. Well, there's a theorem that states if two angles are complementary to the same angle, right? It's called a congruent complement theorem. Then they're congruent. Conclusion, angle ABE is congruent to angle BCE by congruent complement theorem. Right? If 40, if I wrote 40 is complementary to 50, right? Some angle A over here is 40 is complementary to 50. And there's another angle, right? Let's say angle A is complementary to 50. So this is 40. And I call this angle B is also complementary to 50. Well, B and A have to both be 40 degrees, right? So you can clearly see that theorem. Okay, so we've established that these two angles are congruent, okay? So back to the original problem, right? Angle ABE is congruent to angle BCE, right? By the congruent complement theorem, okay? So there's just a little sideways derivation of why these two angles are congruent. Now that you establish this angle is congruent to this, these two angles are congruent because they're 90 degrees. These two triangles here on the right are similar also by angle. Okay. All right. So just a real quick kind of proof, if you will, like why these three triangles are congruent, right? It's really by angle. And so whenever you see a problem that asks you to find the hypotenuse or find the leg, find the height of the triangle. You can use the fact that all three are similar, and then you can set up proportions. And the way I like to solve problems in the next video I'll show you is just to think of everything in terms of leg, hypotenuse, and I'll be a little more specific. Instead of just saying leg, we'll say long leg, short leg. Okay, so this will be helpful when you solve the actual problems, right? This is clearly the hypotenuse. We'll call it HYP. And assuming that you draw everything to scale, okay, because sometimes it's hard to kind of memorize all these relationships. Everyone can see what the hypotenuse is in the original triangle is, right? Call this the longer leg, and this is the shorter leg, okay? Assuming you could see everything to scale. Sometimes the way they draw it in the picture might be a little bit difficult to discern. But for the most part, you should be able to discern which one's longer, which one's shorter, okay? And that will also help you in your similarity statements. I mean, the homework might ask you, write a similarity statement between all three triangles. These are definitely one ways of writing them. And when you actually solve, right, think of it in terms of hypotenuse, long leg, and short leg, which I will go over in the next video.